welcome. This is a wonderful occasion with a beautiful room and a beautiful day. I am Bob Wright. Good afternoon, and thank you all for joining us. This is our third of our Global Speakers Series luncheons. This season's series is focused on issues that impact us all locally and around the globe. As the concern for global warming and changes to our environment confront us each day, there is great concern in our coastal community of the impact on our ocean and to our ocean and our shoreline. Civic Association has been engaging residents in discussions on what we can do to protect our shore, restore our beaches, and protect our sea life. We keep the environment in the forefront through our committees, and we strive to act now to protect our paradise for the future. Our speaker today has conducted extensive research and will share his thoughts on our changing ocean and what we can expect in the future. It is through the support of the Civic Association members that we can have impact on our community and we can educate our residents on pertinent issues. Thank you all for your commitment to our community. We're grateful to sponsors who support our organizations and our programs of interest and importance. Our sponsor today is one of the Civic Association's longest partners, First Republic Bank. We value their dedication, our relationship, and are pleased to have several representatives with us today.
I'm Patty Travis with First Republic Bank. I'm actually the team lead of our newest office, which is located at 4506 PJ Boulevard in Palm Beach Gardens. So we have a full-service preferred banking office located right across the street from Cafe Chardonnay. So if you are in the area, I hope you'll stop by. So I'm delighted to welcome everybody to today's special event. You know, as Bob mentioned, First Republic has been connected with the Palm Beach Civic Association since we opened our doors here 7 years ago at 241 Royal Palm Way in Palm Beach. And we understand how important the Civic Association is to all of you, our clients, and our friends. And we're really proud to support the Civic Association, and we applaud you all for creating special events like today's event. You know, our oceans are really important to the entire planet, not to mention the economic and recreational impact on South Florida. So without any further ado, we think you guys are great. We love you, you love us. Let's move on. Mary, thank you.
Thank you, Patty, and thank you for all that you do for the Civic Association and First Republic Bank. Ladies and gentlemen, as our chairman Bob Wright said, we welcome you to our third program in our global series. And I wish to recognize a newly formed committee of the Palm Beach Civic Association. Would the members of our environmental committee please stand? And we also have our students here from Rosarian Academy, from St. Anne's School, and from Palm Beach Day School. And we thank each of you for all you're doing. And let's give this new committee a round of applause, please. We're very proud of the Environmental Committee's work, and they are focusing on the following issues of priority: reducing the use of pesticides, and to further educate one regarding landscaping using native trees and plants. And then also encouraging the use of reusable bags. And if you notice your gifts today, we hope to see you all in Publix and other places using your reusable bags. And the bags were sponsored by the Peacock Foundation as well. And now on to our distinguished speaker. Dr. Oscar Schofield grew up swimming, fishing, diving, and surfing in Southern California. Oscar decided to pursue a degree in biology and marine science and attended the University of California at Santa Barbara for his undergraduate and PhD, where he conducted research on photosynthesis and environmental impacts of the Antarctic ozone hole. Oscar then joined the Agricultural Research Service in New Orleans before joining Rutgers University, Department of Marine and Coastal Service, as a distinguished professor and department chair. Our distinguished speaker today is a leading expert in seawaters rising, which is incredibly important to all of us here in Palm Beach. Oscar's research is conducted in a range of oceans, from the rapidly warming melting along the West Antarctic Peninsula to sustained studies along the Northeast United States. Oscar recently returned from a 2-month trip from Antarctica. I believe he left on December 26th and just arrived back in the States last week. And here's a short segment from Oscar's documentary.
We have a sea level disaster facing us.
It's a hard job. It's 24/7. It is an extreme environment. It's a very harsh place to work. It's a very dangerous place to work.
The big danger is that you get trapped in the ice. On one of my first cruises, we ended up being stuck in the ice for an entire month.
This is about science. We're right at the heart of some of the largest climate change on Earth. We're right there at ground zero.
In my lifetime, that whole area of Earth has changed. The winter sea ice season is 90 days shorter.
They likely won't make it through the first winter.
There is a complete sense of responsibility. We can't mess this up.
I'm not sure we're going to make it.
And speaking of sea level rising, I believe it was October 31st, 1991, where right here at the beach club, the sea level was so high that it knocked through the windows downstairs. People were actually dining. I believe the late Stan Rumbo was having lunch then. And to the club's credit, lunch service continued. And maybe that's why we're on the second floor today. But in any event, this is an issue that we are all facing year after year. We will begin our program shortly with Oscar and Tim Malloy, and enjoy your lunch, please.
And he truly is, he won't say so, but he said, call me anything you want, but that is what he is. If we could call up the spaghetti model, it's something we're all very familiar with here in South Florida. This is something you know an awful lot of light. Give us the nexus between this and the fact that the glaciers are melting and the fact that Antarctica is in peril. Why should we pay attention to this, and what are you looking at here?
So what you're looking at there is what the Weather Service does. They don't run one weather model, they run many. Because they know that each model has its own problems, and some are better than others. And so if you watch the Weather Channel a lot, they always talk about the European model. It's the best. It actually works much better than the US models do. The US invested in all the technology to give the data to the models, and the Europeans invested in the model. And what you're seeing is this spaghetti diagram is the variability between the model forecasts. And that's what city planners use to plan, do you shelter in place or do you evacuate during a big storm? And so we all know from the hurricanes that they can tell you exactly pretty well where a storm's going to go, but they do a horrible job, not because they're not trying, giving you the intensity at landfall. And that's why surges are usually so poorly predicted. You know, is it a 12-foot surge or a 5-foot surge? And the reason it's very difficult to solve that problem is you don't want to send a human out in the ocean during a hurricane. As someone who's been in a hurricane at sea, it's miserable. Trust me, you don't want to do it. And researchers don't want to go or send their students, because if they lose a student, that's a lot of paperwork. Yeah. And so what's happened in the last decade in the United States is ocean technology's undergone a revolution with robotics, drones, satellites, and models. And that's why we can now make much better forecasts, but we still have to do the intensity problem. And the intensity problem is the ocean. The atmospheric models do really well. The ocean models actually negatively impact the forecasts. And the reason is you've invested, all of us, trillions of dollars in a Weather Service to measure the atmosphere, but there's very little investment in the ocean models and the technologies for that, and that's just starting to change. So that's why you care, and we've flown robots into Irene, Hurricane Sandy, because we're in the Northeast, and have sort of found out some of the underlying physics of why the models do so poorly. So that's one part of my job as a technologist, of how do we actually not have to have humans at sea all the time. Why should you care about remote parts of the ocean? I just returned from Antarctica 10 days ago. It was my 20th time down there, and we're working off the South American side of Antarctica. And you might have been following the news. There was 60-degree temperatures in Antarctica a few weeks ago. That was when I was steaming home. I was south of the polar circle, which is very, very cold generally. Atmosphere is very dry because it's so cold. And we were having pouring rain for about a month down there. And
you've never seen that before?
I've never seen that in all the years down there. South of where I was, there's an ice sheet called the Thwaites ice sheet. And there was a New York Times article that they found 3-degree water underneath the ice sheet. What that means is that ice sheet is going to collapse. It's the deep ocean that's coming under the ice. The big science problem is if you ask me, I can't tell you if that's 5 years, 10 years, 100 years. In part because the data collected this last year was the first time they actually got measurements like this. When ice collapses in Antarctica, it's what raises sea level up here in the northern hemisphere. When the Greenland ice sheet, if it collapses, it raises sea level in the southern hemisphere. And so the Thwaites ice sheet, which we know will collapse, and it might take a really long time, the estimate is anywhere from 2 to 3 feet of sea level rise. So we're not talking inches or this or that. I'm an optimist, so the movie trailer is very melodramatic and everything like that. But we have time to respond, and the hard science right now is, when is the system going to shift?
So if you and I were to take a walk along the Intracoastal right now, on certain days, the water would be coming up over the banks off the lake here. Is there a direct correlation between what you're talking about right now and that? Are we seeing glacial melt? And then further, what's our future if that's the case? And how long do we have?
Well, that's the big million-dollar question. There's a lot of weather, right? You have cold winters, you have hot winters, and that's just natural variability. But underneath that natural variability is a very, very slow and small sea level rise. A centimeter, a year or 2 years. So it's very hard to see the climate signal because of the huge swings of weather. And so often you have to look for decades to be able to extract that climate signal. What we do know is that the sea level is rising and the ocean is getting warmer. And so the best measurements of the ocean getting warmer are in the deep ocean. And it's raised 0.02 degrees. And that sounds very small, but water holds heat 1,000 times better than air. And so even if you were to shut down fossil fuel, you've built up a huge heat engine in the deep ocean that will take decades to off-gas. So we're still going to see the problem even if we knew what the solution was. What you're going to see here a lot, and what we see off New Jersey, actually the Northeast has the highest sea level rise on the planet. Part of it is the land is sinking. It's called subsidence. And then you combine that with the global signal, that's why we have a very larger one. You have less subsidence here in Florida, so you're more closer to the global mean and everything like that. But the things that are going to affect us much more from climate are going to be storms, because the ocean is getting warmer, and that's the fuel can for large extreme storms. And the storm seasons are lasting longer. Hurricane Sandy hit a few days before Halloween. And the hurricane season really ends, towards the very beginning of October. And so a lot of the things we take for granted in terms of when storm season ends how many category 3s, 4s, or 5s we experience, that's what's going to change. And so that's why we need this better technology to help us respond to the change.
Most of us probably weren't aware of the land is sinking part, which I'm trying to let sink in. But
Yeah.
The Dutch build dikes. There are people who have ideas even for Palm Beach on that. Is this reasonable? Or
I think that's actually what humanity is going to need to do. You know, if you look at the long run and you look at the worst projections, which are probably not the case, right? You know, you're going to have two choices. You can retreat or you can engineer. And the Netherlands is below sea level, and it has been, you know, forever as far as my life is concerned. And they've managed their waters very effectively. And that's what you're going to see. You know, we're not going to move New York City. Palm Beach has a long, glorious history there, and it'll continue. But we're going to need to become smart with our infrastructure for the new reality. You know, and the good thing is climate is slow. Because it's a global phenomena. And so there is plenty of time to make smart decisions. I'm an academic, so we should let smart people design that part. So I don't do that so much. But, you know, the reality is you know, we're going to be building a lot of that new kind of engineering. You know, and there's all kinds of proposals for New York City. You know, do you build dikes that close at Sandy Hook up to the city, you know, and protect from waves? You know, that's, I don't know if that can be done, you know. But how water responds and how it has a place to move and this or that, I think there'll be a lot of that kind of work going on. Water tables are going to be the big thing you're going to need to worry about. So if you look at Miami, as sea level rises, the salt water gets further and further into the water table. And so how do you protect those or guarantee fresh water? And so the next generation are going to be really charged with figuring out these new infrastructure capabilities just to deal with the reality on the ground.
we have the next generation here, and they are going to ask a few questions. We got some students from St. Anne's, Rosarian, and Palm Beach Day. But before we do that, and then open questions to anybody, because I'm sure people have a lot. You teach at Rutgers. I mean, you're around young people. These are the active. It's their future. It's their world. You don't hear much. I'm not getting political here. You don't hear much about this in the campaign, or you don't. Generally, it's not in the dialogue much in America, or maybe not enough. Are the young people the people who are going to be at the vanguard of trying to fix this?
Yeah, I mean, the great thing about working in university, you meet a lot of great kids, and I'm old enough now I can call them kids, and I leave more optimistic every day when I go home than when I go in, because they're smart, they're hardworking. But if we throw politics away, we all know we have to deal with it. If you go talk to the Joint Chiefs of Staff of a pretty conservative organization, climate is number 5 of their global threats. And the reason is you're going to change where rainfall happens. And that's going to destabilize food and lead to mass migration, where you're not talking about millions of people moving, you're talking about billions of people not having water for food or farms. That's why we have pirates off West Africa now. Used to be farmland that is now dried up, and they are going to have another job. And what they found is piracy is the best sequence. You know, and so there's many smart sides from all sides of the political spectrum working the problem on a different one. You know, I mean, the problem with politics is it's a contest, and so it gets very strident. But if you look at both parties, they have a long history of supporting science, supporting engineering. And, you know, at the end of the day, we're all going to want the same thing, which is healthy coastal communities. You know, most of humanity lives at coasts. 13 of the 17 megacities of the planet are right at the coastline. And if you look at China, the equivalent of the population of Spain moves from the inland China to coastal China every year. And so, you know, these megacities are going to continue to exist. It's more engineering around them. And those young people, they're the ones who are going to be ready to do it.
Let's go to Mitchell. Let's go to one of the students, and then we'll get to the rest of you. Which one of you wants it? Who gets the mic?
Over here.
Come on, we
Yeah,
talked about
perfect.
this.
We'll have you stand up, too.
In how many years do you predict that like Palm Beach will be like underwater?
Are you going to hold me to it? Yeah. I think, it's not going to happen probably. At first, I don't think Palm Beach is going to be underwater. I think what's going to happen is your table is going to need to fix it so the water drains differently. The things we're going to need to do are things we never had to do before. So how do you deal with incredibly strong storm surge? How do you develop waterways so that they can handle a higher sea level and minimize damage, on land? But what we're finding is a lot of the predictions of climate, there's spaghetti models for climate, just like the Weather Service, and they all predict the same thing. And what we're finding is the changes we were predicting are happening earlier than we expected. And so it's going to be more of an urgent issue to figure out how we deal with these things quicker. So I think Palm Beach is still going to be here. I hope so. I've had a great weekend. And so, and I think that, it's going to be a question of how we deal with the environment.
One more student, then we'll get to the rest of the group. Which school are you?
Rosarian.
All right.
Is the coronavirus because of climate change?
No. And I'm not a medic, so that's about all I'm willing to say. So.
Any of the other young
Anyone else
folks?
have a question over here?
I'm from St. Anne's. Do you think there's been like more flooding since, and like involved with climate change? Like in England, I saw that there's like towns flooded and stuff.
Yeah, so if we just look back, the last 10 years, and if you just look at the U.S., the number of megastorms that have hit us has been pretty dramatic. I can't tell you definitively that this storm or the last 3 storms were climate, but if you just look at the frequency of storms, they're going up. The thing we've been seeing with the storms is they tend to carry a lot of water. So Houston was a great example, where essentially the storm hung out there and flooded for days. And as you warm an ocean, you essentially set up the condition where you can really load up these storms with a lot of water. And so when Katrina hit New Orleans, it was a weak storm. I mean, it was a huge storm, but it was weakening. And then it happened to hit a pocket of cold water right before landfall. And that's where it intensified and then really walloped the city. And so you do see storms going further north, like England, this or that. And if you don't have a warm ocean, you don't have the fuel can. So for those of you who are in the Northeast, Irene was way over-predicted in terms of intensity. So if you remember that, we had our very delicate Governor Christie at the time on the beach yelling, "Get the hell off the beach." And it completely over-predicted the storm, and he ended up, when we evacuated everyone away from the shore, which wasn't very badly damaged during Irene, but we evacuated everyone into the flood zone of all the rain. And it was simply because we had the wrong ocean in the model. And so those are the things we just need to fix so we can deal with things smarter.
Anybody out there? You may not need the mic. Michael, hang on. You got a big voice.
How did Sandy become much worse than was predicted?
So what happened with Sandy is, so if you look at the Northeast United States in summertime, much less than you have off Florida here, is you have a 2-layer ocean. Super cold water coming from Gulf of Maine area and left over from the winter over super hot water. When Sandy came, that water had already mixed and was essentially a single temperature. And when it made the bend and came straight into the city, it essentially strengthened offshore, but it was so big, it pushed that wall of water that was one temperature up into New York City and New Jersey. And the problem is the way we do intensification now for the Weather Service is use a satellite, and a satellite gives you the sea surface temperature. And once you have clouds, you can't see through the clouds, so you have to assume the ocean hasn't changed. And so that's the fundamental error in it. And so what that requires is you develop new technologies that can be in the ocean but communicate to shore fast enough. And so that's where a lot of the new robots and everything come in. You know, but this is the problem also for the Weather Service, is they can only do a 48-hour forecast with a lot of error. And the town planners, they operate in a 64-hour time zone. They got to make the decision in 64 hours, evacuate, or just close your storm windows and sandbag. And so we're still developing the technology where we can actually impact a city planner in a good way of managing what the response is going to be. But Sandy, the thing that really was dramatic was to have a storm that late and that preconditioned the ocean to create just a wall of water flooding into New York.
In your opinion, what are small behavioral changes that we can make to mitigate the rising temperatures?
Yeah, I mean, I think you already see some of the big things happening, right? So you're seeing lots of different energy sources. There's going to be no magic bullet. We're going to need petroleum for our modern economies. But if you look at solar and a lot of these things, they're very important. You're probably going to need nuclear, actually, because it's actually carbon neutral. But I think what we see changing now that's more important on the small local scale is, one, people are getting enough confidence in the models to use it to plan proactively to a storm, keep people safe, but then have essentially the materials close enough to get in and repair quickly. And then also the design of how we design our coastlines, our coastal cities and this and that, at least cognizant that they should be built with enough rigor to handle some big surges and then not treat it as a surprise. Yeah.
Yes?
Maybe I missed something, but I'm not really clear. What is causing the rise of temperature?
Yeah, what is causing the rise of the seawater temperature? What is the source of this?
So the temperature of the planet is increasing. There's natural variability over geologic scales. But when you burn carbon that had been stored in the Earth's planet, you release CO2 to the atmosphere. And the CO2 captures infrared energy bouncing off the planet. So that's what's warming the atmosphere. And then that carbon and that heat's being sucked up by the ocean. So about half of the heat or carbon that humanity, because of their activity, has put up has been sucked up by the ocean. You know, and so if you think about it, it took the Earth, you know, I'm not a geologist, but 10 million years to make oil. And even if you take long-term forecasts, we will have burned it in 2,000 to 3,000 years. And so you can't put that much carbon up in the atmosphere and not have an impact. Yeah. I usually talk Celsius. Yeah.
Go ahead.
Here you are, sir. Here you go.
Back to the dynamic of global warming. But you look at, if you will, population. In 1800, we had 1 billion people on Earth. Yeah. Today, we have, broadly speaking, 7.5 billion. And I read a study recently that said by, say, 2050, 70% of the population, the world's population, will be living in urban areas. So when you think about the exponential increase, going back to your point about carbon emissions, how does that play out for you in terms of impact on the global warming and melting and sea rise?
Yeah, I mean, I view it where, we have very strong modern economies, and that's a great thing, right? If you think about the number of humans, if we went back a few centuries, we wouldn't have been able to feed them all. So the fact that that's a good thing. But what's going to happen is the race, the transition time it takes to diversify our energy. We're not going to give up energy, and I don't, I want my lights and my heat and everything like that. But how do we diversify quickly? And if you look at the costs and impacts of solar energy, it was cost prohibitive a few decades ago. And now if you look at countries like Germany and some of the Northern European countries, a huge amount of their energy is coming from these technologies. And that's where I think humanity is really smart. And when we have a global problem and we face it together, we usually do really well. And despite all the, histrionics on both sides, I'm still an optimist that I see a lot of things already happening that are going to help mitigate that. Urbanization, to a certain extent, it depends who you talk to. Some say it's going to lead to more CO2 emission, others say less. And the less would be that you don't have as large a footprint in terms of the number of people you're heating. You heat 1,000 people in a building as opposed to suburbia where you might heat 1,000 homes or something like this. The science on that side of stuff I would consider looser than the geophysics. The geophysics is the geophysics. And there's a lot of people working on it. A lot of people are seeing it as an economic opportunity. There's people buying land now that are going to be better farm areas for certain crops. And so if you look at California, the wine crops are moving north towards Oregon and Washington. And so if you got some land in southern Washington, you should put your vines in now, because in the 5 or 6 years they've matured, you'll be ready to fill a gap, because Southern California is going to run lower and lower on water.
Are we at an unprecedented sea level ice melt moment in history? In other words, is this 100,000 years ago, did this much of Antarctica melt and then rebound?
Yeah.
So this is cyclical.
There's two things going on. There's a cyclical cycle to the planet. And so, the people who say, yeah, the Earth has always changed, that's absolutely correct. Antarctica used to have alligators. It had forests and everything like this. It was also a little bit further to the north. The difference we're seeing now is the rate of the change is much faster than if you look back in geologic history. And so the question is do systems have time to respond? There's going to be winners and losers in that. So where I work with the penguins, there's two types of penguins in Antarctica now. There's the penguins who live in Antarctica all the time. So that's the emperor penguins, happy feet, and the Adelie penguin, which is, a little bit shorter. And the Adelie penguins where I work at Palmer Station, back in the 70s, had 2,000 to 3,000 breeding pairs. There's about 500 left there. And there's a variety of reasons why. But it doesn't mean that life ends. We have penguins now that used to be further towards South America, now moving to Antarctica and settling in and growing there. Soil is being formed on the continent, and probably by the time those students are the leaders leading the rest of us, there will probably be rooted plants in Antarctica. So it's not unprecedented that we see huge changes. What's unprecedented is that, one, it hasn't happened since humanity has been such a dominant force on the planet, and it's happening so quick.
Yes.
Yeah. Yeah, so he was asking about the level of carbon in the atmosphere. You can't stop it quickly. So if we shut down CO2 emissions today, the planet would continue to warm for at least 100 years, just based on the heat that has been stored in the ocean. And there has been times where we had very high CO2 in the atmosphere, higher than we have now. But the difference was if you look at New Jersey, it was about 20% smaller. The ocean actually took a huge chunk of it. all the islands, nations that you find in the Pacific will be underwater. And that is likely to happen in the younger crowd's lifetime. And so the thing that is going to be that's going to create instability isn't that the Earth is changing, but now humanity has set up this whole political economic system that is going to be threatened over the long term. What do you do with people who lose their island? So there's a lot of negotiation going on of where, which developing nations should absorb them, or do they do it equally, or this and that. And these are really complicated, thorny issues, but it's actually time where you have to start thinking about those things now.
We have time for two more. One of the young guys, and then we'll do two more. Students.
How are people planning to defend from these bigger storms and like hurricanes?
So the first thing we need to do for bigger storms is to be able to tell a town you're going to be hit this day at this strength, and the surge is going to be 15 feet, let's say. And that's a technology that's developing really quickly. 2 years ago, from the Caribbean spanning the eastern seaboard and the Gulf of Mexico, universities, the US Navy, and NOAA had 100 robots creating the first ocean network ever on that scale in history of humankind, essentially for hurricanes, to see if we could do it. And so we can actually develop that technology. It's not satisfying in the sense that we can stop the hurricane, but one, we can respond to it very quicker. When Sandy hit New York, they pre-positioned all the recovery trucks to get in right away. The surge model that was going to say how high the waves were going to be were off by 12 feet. And they parked the entire fleet of trucks 1 mile too close to the beach. And so if we think of what we need to do, we need to improve the forecast to save infrastructure. The problem is Asia. So we measure it in billions of dollars of damage. You can take all the other natural disasters, and hurricanes account for half of the deaths and half of the infrastructure, even when you combine earthquakes, fires, tornadoes. Asia, they still measure it in how many people died. That's the metric of a bad storm. So we're doing better because we're not really talking about that. But every storm is billions of dollars of damage. And if we get more, how do you build a system that can essentially absorb those huge economic hits?
Michelle, hi.
How does the rapid change in rise in temperature affect sea life?
The temperature actually will affect where you find certain sea animals. Florida is very, I consider it sort of tropical, because you don't have huge excursions of temperature. It gets a little colder in winter, a little warmer in the summer. If you look at northeast off New York City or New Jersey, we go from 6-degree water to 30-degree water in 4 months. And so what you'll see is the fishes are moving. So a good example is a scallop fishery in the mid-Atlantic. It's the most profitable per capita fishery in the country. It was a disaster 10 years ago. The temperatures have risen now where it's perfect for scallops. The South Atlantic scallop fishery is collapsing because it's getting too warm for the scallops to be there. So the animals and the fish aren't dumb. They're going to migrate. And so if you have local industry or this or that, you got to respond to it. The other thing that will happen to sea life is the ocean will acidify. So as you suck CO2 into the atmosphere, you lower the pH. And the numbers they talk about sound tiny, 0.01, 0.05. But the problem for pH, it's a log scale. So a lot of the burning questions that marine scientists are really focused on, will coral reefs dissolve? Because they're made from calcium carbonate, and if you make things too acidic, reefs dissolve. And there's huge debate. You could get 3 scientists up here right now because we don't know, and we would all debate, what the answer is going to be. So there's going to be winners and losers, but there's probably going to be huge regional shifts. So if you're a fisherman here, you should probably be looking at the state of the Caribbean now to know what you're going to be fishing in the future. You know, New Jersey's now getting much more of the South Atlantic fish coming up, and the New Jersey fish are moving up to the Gulf of Maine.
We've got one more. Bob?
Florida has an enormous amount of shoreline. Is there any particular difference between the east side, east and the west in terms of our ability to climate change?
Doctor, could you redo the question?
Yeah, so the question was, if you look at Florida, you have huge shorelines, face, east and west, and is there one more sensitive to climate change? I can only guess, because this isn't my field, I'm not an expert in that, but what you will see is the eastern side will deal a lot more with the energy coming from the Caribbean. And the hottest pool of water on the planet, actually, in the ocean is off the Caribbean, and it's going to get warmer. So I think that the impact we're going to see for climate change on this side is going to be storm impact and just being exposed to that. The West Coast, in my experience, where I've been, tends to be marshier. And so the idea of land sinking as water moves in is going to be larger. And that impacts things like red tide. So you've had a lot of chronic red tide down here. And the conditions are better for red tide as ocean gets warmer. So.
And a final question, do you name your robots?
No. Well, we did. So we have a fleet of, we call them gliders. They don't fly by propeller. They fly by changing their weight. They suck a coffee cup in their nose. They sink. They push the water out. They float up. And then they call home every so often. So they call New Jersey. And so our students can be part of the experiments.
Well, if you might consider naming a robot the Palm Beach Civic Association and sending us your information.
I'm happy to
along the
talk
way.
about naming opportunities. But the reason we don't actually, we were starting to name them, and we do a lot of global missions with these robots. And we were in Spain, and we had a robot called Francis Drake. And I was culturally unaware of the degree to which they despise Drake. And so right now it's Rutgers Glider 32, Rutgers Glider 33, and everything like that.
Oscar, we thank you so much on behalf of the Palm Beach Civic Association, on behalf of First Republic Bank. It's been a true pleasure to have you here. You're always welcome back, and we do have a gift for you.
Oh, thank you very much.